Hello, everyone. A very good evening. Welcome to ThoughtWorks Geek Night organized by Pune. I'm Gayatri Kodak, working as an application developer at ThoughtWorks. The topic for today's Geek Night is Modernization of Reporting Solution with Cloud and will be presented by Rahul Auti. I will now hand over to Rahul to introduce himself and to the topic. Over to you, Rahul.
Okay, thanks Gayatri. Thanks all for joining. I'm Rahul, based in Pune, working in ThoughtWorks as data engineer. I'm having 8+ years of experience into data engineering space. I've worked into finance, retail, healthcare, and educational domains. Do you want to share, Gayatri?
Is my screen visible to everyone?
Yes.
Yes. So today's topic is modernization of reporting solution. And we have solved this using Azure cloud. However, this can be solved using any other cloud providers. And in this talk, I'm going to share our approach without going in depth detail implementation of it. I'll share high level view and one of the way to modernize the reporting solution today. By end of this, you'll have the high level understanding of solving reporting solution on cloud. So let's start with the agenda first. We will take a look at the problem statement first. And after that, we will see the approach of data ingestion and conversion of OLTP data sets to OLAP using different data modeling techniques. We will also see how we have solved it using the dimension modeling technique. Then we'll see why we have used databricks lakehouse architecture and also check high level design of our data pipelines. And that is again 10,000 feet view of our data pipelines, not without going in depth detail of each and every implementation of the pipelines. And at the end, we will try to answer the questions, if any. If you move to the next slide.
Sure, Rahul. Folks, please add your questions in Q&A section if there are any.
Yeah. So let's understand the problem statement first. In order to understand the problem statement, we need to understand the organization structure. So a client came to us and a client was having a software which was quite old, and it was being sold to multiple organizations. And that software is purely desktop based application and has spread across all of the business domains. So it was complete end-to-end ERP solution. And for the simplicity, we can relate it with the healthcare providers like Apollo or Sahyadri. So each of them are group of organizations where each group has multiple hospitals or organizations in it. And more of that number of organization in each group is in 1,000 in our case. And there are a few reports which needs the data from government data sets as well. And now if the leadership team wants to see the reports, then think through the underlying complexity of the process, getting data from multiple sources, getting data from outside world, getting data from internal domains. It is fairly complex process. And considering the complexity, building automated reporting solution would make more sense rather than relying on legacy semi-automated error-prone spreadsheet-based reports. And the business is spread across UK region, and they have around 20,000 organizations connected, where each organization has more than 2,000 tables. So data was sitting into more than 2,000 tables into respective databases of every organization. To build the reporting solution, data aggregation is one of the crucial thing, because to generate the report, we need the data from different organizations. We need to aggregate it, and on top of it, we have to show the numbers to the leadership team so that they can take the better decisions for the future. Another trickier part here is there isn't any unification in terms of underlying databases tool used in every organizations. So there are multiple organizations. Organizations were in thousands, and there are different different databases tools are used depending on the organization, and few organizations are even using SQL Express. And again, that is shocking, because SQL Express is not meant for production workload. It is used for learning purpose only. But we had that scenario where a couple of organizations were running SQL Express as their production database server. At the end, they wanted to leverage this aggregated data to run AI ML workloads as well. And in a nutshell, we will end up building shared data platform, which will be used to onboard future use cases. But for now, for this presentation, we will focus on a reporting solution only, how we have solved our reporting use case there. On the following slides, we will see how we have dealt with each of these problems, starting with the data ingestion layer. Okay, so in the data ingestion layer, our first hurdle was to get the data out of these on-prem systems and onboard it on the cloud. So for this, we have built data ingestion pipelines using Azure Data Factories. But at first, when we started with this program, we initially tried different tools to actually onboard the data. First approach was we used Debian and Kafka Connect framework, and we had to drop that approach due to reasons like underlying databases were not offering support to Kafka Connect framework because few of them were running on the SQL Express. And main restriction was the organizations were not allowing us to install anything on their on-prem databases, because if you want to get the data out of their system, you'll need to install few frameworks on the database servers. But organizations were not allowing us to do that. At the end, we had to go by a route which was tried, tested, authorized, and approved by these organizations, which was legacy data extraction layer. And this legacy data extraction layer was already built, and we simply extended that. So we actually plugged in our data factory pipelines to extract and sync the data to ADLS blob store. If you see in the diagrams, there are client applications which are running and writing data to their respective databases, and there is data extraction framework which is mounted on top of those database servers. And the data extraction layer is pulling that data and building its own cache database in the cloud, and they have their REST APIs running on top of that cache database. And we simply leverage those cache database and those APIs to build our data ingestion, to build our layer, which is first layer in our architecture. So when we started with this approach, we know this is not the right way to do the data extraction and data ingestion, but this was the only option we had due to business level constraint. And again, this was just an point in time solution. Eventually, everything will be moved to the cloud, and there will not be anything running on-prem. So this is just a point in time solution, and we have used Azure Data Factory to get the data from on-prem system and put it into the Azure Blob Store. So we have used ADLS Gen 2, which is Azure Data Lake Storage Gen 2 Blob Store, to store the raw data. On the next slide, we will see what we are doing after getting data into our environment, which is on the cloud. So the data is getting ingested into the Azure Data Lake Storage Gen 2, and we created a container for that, and we are calling it as raw layer. And there is obvious reason why we are calling it as raw, because this is just a dumping ground and nothing is getting standardized here. So the raw container is an simple entry point for all of the data sets. And there are few data sets which are internal to the organization. There are few data sets which are external to the organizations. Data sets like government data sets are external to the organization. So we have logical divided that raw layer into multiple logical folders based on our need. So there is staging, landing, and actual data folder as well. So in raw, we are writing data as is for easy reconciliation. And most of the data getting ingested by calling REST APIs. And because of that, we have to use the JSON as a file format. Though JSON is not the optimized file format for distributed processing, but due to simplicity and the way of the nature of our data sets, we had to choose that for our raw layer only. One more thing to note here is in raw layer, we are dumping data as is. We are not doing any kind of modification. Nothing is getting done here. And we have built generalized data ingestion framework using data factories, and that is also getting reused to onboard new domain onto our platform, which is lakehouse architecture. In the data ingestion pipelines, we have fully automated it, and all of these data ingestion pipelines are fail safe. So these pipelines are taking care of failure scenarios and has self-healing ability, and we are using control tables for that. So just to give a quick heads up how we have handled failure scenario in data ingestion is, at very first step we have done is we have carefully chosen the partition strategy so that it will be easier for us to recover from failures. So data is getting partitioned by ingestion date first, and after that we are partitioning by unique identification number, which is organization ID in our case. So data is kept in isolation in terms of ingestion date as well as organization. As of now, we are pulling data daily, but since we have designed and developed customized data ingestion pipelines, and that pulling data daily is completely configurable. We can even pull multiple times in a day. So we have solved it completely batch way. And there was a client need stating that why can't we solve it using real-time way. So if you were able to recall at first thing, we tried Devism and Kafka just to factor in those requirements as well. So due to few reasons, we had to drop that approach and we had to shift to the batch approach, and then we landed building data ingestion framework. And again, we have taken full approach for the data ingestion. We also leveraged Azure table storage to store the control tables. So the control tables are used to recover from failure ingestion scenarios. So this is very similar of checkpointing in any queuing system. So if there is any failure while data ingestion and the partially ingested data gets quarantined, and ingestion pipeline will actually restart from the failure. And data ingestion pipeline will only be moving data to actual processing folder only after successful ingestion. So there will not be partial ingestion. There will be successful ingestion only, and then only we are processing it. Otherwise, we are quarantining that data, and we are making sure that pipeline should rerun by itself, and by giving some amount of delay for the systems to reheal. So, and we are following historical load followed by daily data approach to ingest the data. And this data which is getting ingested, it is transactional data only, and it is fully normalized OLTP data, because we are calling REST APIs, and REST APIs will give you the fully normalized data. On the next slides, we will see the OLTP conversion of OLTP to OLAP using dimension modeling technique. Okay. On successful completion of data ingestion into the raw layer, we introduce one more layer, which is silver layer, and this is we are calling it as a domain layer. In our case, we leverage databricks delta tables to populate the domain layer, and we are calling it as lakehouse architecture. In this layer, the JSON transactions will get converted into the Parquet-based analytical tables. Since data is pulled by calling OLTP system, it's necessary to convert these OLTP transactions to OLAP, and OLTP transactions are fully normalized, right? So if you need data which is, if you need read intensive tasks, then you'll need to convert your OLTP system to OLAP system. So if you use OLTP data for analytical purpose, we will end up with joining multiple tables, because data is fully normalized and with so many filter conditions. And again, that will lead to slower execution and a slower read time. Hence, OLTP to OLTP conversion is very crucial for any of the reporting solution. And there are multiple ways of actually doing it. In our case, we took Ralph Kimball dimension modeling approach for this. And there are reasons why we have chosen dimension modeling approach for this. One of the main reason was we had to solve this very quickly by keeping things very simple. And And once we get something out of the door, then we'll have time to revisit this later, and we can factor in another approaches. It can be data vault, or it can be something else as well. So for the reporting, we need to keep track of changes over the period of time, right? So that we can generate the meaningful insights out of it, and which is not possible if you use OLTP for that. Because OLTP uses relational database management tools, and which are well known to keep the current state or current status of your running business, not the historical data. Right. In order to maintain the history and lineage of the changes over the period of time, we have to use something SCD type 2 dimensional.
Okay, I found this on
SCD type 2 dimension tables, whereas each change will be appended as a new row to the table, and there is flags to identify the current state of a record. So let's say something is getting changed. So older records will not get overridden, new records will get added, and there will be flag to invalidate the older records and flag the current record is valid. And we have also built fact tables to get the statistical data, and most of the fact tables are factless fact tables because of business scenario in our case. One important thing note here is that we are not applying any kind of aggregations in raw to domain while copying data from raw to domain. We are simply converting OLTP transactional data into OLAP data store using Databricks Delta tables. So we build domain layer by applying a few standardization rules. And again, these standardization rules are very specific to our use case. Right. To build the dimension model, dimension model in the domain layer, we actually selected highly scalable execution engine, which is Apache Spark, and there are multiple Spark jobs that are running in chain to convert these OLTP data sets to OLAP data store. While building these pipelines, we need to decide the sequence of table so that it will be easier to generate the report. So in our case, we used lookup dimensions to populate first, because lookup dimensions are getting used to populate subsequent dimension tables. So lookup dimension should get processed first, and after that other dimensions. And at last there should be facts should get generated at the last. In this layer, again, we have used Azure Data Factories to orchestrate these Spark jobs. And another thing to note here is, again, this layer can be solved. There can be multiple options to solve this. It can be Snowflake or other similar tech stack. But in our case, we have chosen Databricks Delta Lake, and there are reasons to it. So we will discuss those reasons in next slide, why we have chosen Databricks Delta Lake and lakehouse architecture for this. Okay, now coming to why question around Delta Lake. We consider other options as well. However, we were in search of something which is highly scalable and proven for its scalability, as we have to deal with high volume of data. So we had to deal with data coming from 20,000 organizations. And the first execution engine came into our mind was Apache Spark, because Spark is already in industry since long, and it has proven its scalability in the industry, and the tools which are backed by Spark. So in future, we'll be getting the data real time, and there are other domains where we are expecting data in real time, and we need something which can cater to Lambda architecture. Like, we need to solve it with batch and real time, and we should have something in our hand which should scale for batch and real time use cases both at the same time. And there should be feasibility to query the data, right? If analysts wants to query these fact and dimension tables, there should be some provision to do that, right? So Databricks SQL has the capability for that, and it has Databricks SQL workspace, and which is very useful for such kind of scenarios. And there is also future use cases where we are expecting AI ML workloads and models should leverage these delta tables for their own analytical purpose. And Databricks Delta has very good integration with MLOps and time travel feature of Delta tables. And there is ML flow, which is by default embedded into the Databricks subscription, which is again very useful for tracking and training ML models and deploying it into different environments. And there are reasons why we have, and these are the couple of reasons why we have chosen these database lakehouse architecture for this. On next slide, we will see high-level design of our data pipelines and how we have designed our data pipelines to actually solve it end to end. Okay. If you take a look at high-level design of our data pipelines, it has three main layers. First layer is data acquisition or source layer. Another is Delta Lake or Lakehouse layer, and third one is reporting layer. So what we have done is we have seen that data ingestion and automated data ingestion framework. We have also seen OLTP to OLAP conversion in previous slides. And from the domain layer onwards, right now we have not introduced gold layer in this architecture because for time being, we have connected our domain layer directly to the Power BI, and Power BI is directly consuming the data from Azure SQL and from Delta tables. And we'll be building one more refined layer, which will be called as gold layer, and where we will do all heavy business aggregations. And for as of now, for the MVP, we shifted those aggregations to the reporting layer, and we are parallelly converting those aggregation and pushing down those aggregation to the Spark layer, and we have a couple of benchmarks for them for those aggregations as well. So we had aggregations running on the reporting layer and aggregations running on the Spark layer or backend layer, where Spark is well proven, and the moment we started pushing those aggregation down to the Spark layer, it started getting executed very quickly, and that was the reason why we have chose the Spark and highly scalable data processing engine for that. In design, post delta tables, right? We can see Azure SQL, and one can ask the question, why can't Power BI directly talk to, or your reporting layer can directly talk to your delta tables? It can. We have the Power BI connectors out of the box for the delta tables or delta lakes, but there is a reason why we are not using it. The reason is we had to introduce SQL in between because of the authorization framework, which is legacy authorization framework for tenanted access control. And that framework is not compatible with delta tables because that framework is specifically internally designed and developed by the client, and it has no compatibility with the delta tables. So it has the compatibility with it is well integrated with Azure SQL. So we had that option, and we added Azure SQL in between Delta Lake and reporting layer. Now our ADF pipelines are pushing daily point-in-time data to Azure SQL. So we are not keeping historical data into the Azure SQL. We are keeping historical data into Delta tables. Only point-in-time real-time data gets copied over to the Azure SQL. And we have Power BI workspaces and REST API mounted on top of that SQL layer. So, and we've also built a React application to render the Power BI reports. And this React application is very useful in terms of giving seamless experience while browsing report. And user can simply log into that React application and check the reports. And again, that React application is web-based application, which means it has multi-device compatibility. User can log in from their tablets or cell phones and take a look at the reports. And one more time, again, we have used data factories to automate the orchestration pipelines from domain to aggregate. And it is not yet out, it is not yet productionized, but we have built those and using aggregate to SQL as well. So during this whole process, right, while solving this getting data out of your on-prem systems and building your report out of the system, there are multiple learnings we have, and we wanted to share those learning. There are multiple key takeaways as well. So in next slide, we will see those learnings. Okay. So our majority of efforts gone into building reusable data ingestion framework, which is again not the best way to handle the data ingestion part, because data ingestion is very trickier when it comes to deciding the approach, right? And if you want smooth data ingestion or data acquisition, our suggestion is to never go with pull approach. In our case, we didn't had any other choice, and we actually went into that pull approach, and we were aware that this is not going to be always always used approach. We'll be converting that pull approach to the push approach. So this is one important key takeaways from this. We have faced difficult time in keeping our raw layer in sync with the source systems due to pull model, and again we are not aware about the changes that are happening at the source end. We were pulling the data once in a day. We have scheduled our job in off business hours, so that we'll not have the data discrepancies or any consistency issues. But again, this is not foolproof solution. One more lesson is dimension modeling technique, right? It is very good where you have very small business domains to solve with very less complex business domains, and it is not highly scalable actually. If you compare this with data vault, then it is not that scalable. In our case, we were aware about this, and we intentionally gone into this dimension modeling because we wanted to keep things very simple, and we wanted to get something out as soon as possible. We have also seen that we have also faced the issue of onboarding new domain into the reporting solution, because we were maintaining the data, and the team was having limited understanding of domain, and we are getting data across all of the business domains, right? Because reporting is a use case where you are expecting data from multiple domains aggregated in centralized space, and then after that you'll generate the reports. Again, this is very tricky to handle because we are keeping that data which doesn't belongs to us, and moreover we don't have any control over that data, right? Because it is owned and published by some other domain. We are simply keeping it at our end, and we are solving reporting use case. So this is not the right way, or this is not the scalable approach to do it actually. There is another important key takeaway from this architecture is we try to solve it using monolith approach. However, we had the issues in scalability. Again, we had to go by that route because our use case was filled with assumptions. There were a lot of assumptions, and we were aware about that, and we had planned around this, and we started with the journey by keeping in mind that in future we will shift away from monolith approach to something very similar to the data mesh, and we spawned up our teams and code bases and workspaces like that. So we already started with future mindset around that. So we'll be converting our monolith approach to the something very similar to the data mesh, and we will be solving by pushing data ownership down to the domain layer. So if let's say if in the report, right, you want the data from financial domain, you want the data from HR domain. So in current monolith approach, what we are doing is we are getting data from financial domain, we are getting data from HR domain, we are keeping it with us, and we are harmonizing it, standardizing it, and then publishing it into the reports. In a way, we are actually owning that data. However, that data really doesn't belong to us, and our team needs to gain the domain knowledge of finance as well as HR. Where it comes to the domain knowledge, this data engineering team and other devs are always in a grilled mode because of crunching between consumption layer and the source layer. So we'll be building domain driven data products, and now data will be in future, right? Data will be owned by the domains, and they'll expose that data via their own OLAP data stores. So there will be multiple OLAP data stores, probably one OLAP data store for each domain, and we will consume that OLAP data store directly, and we will render our reports on top of that. And we are trying to move away from monolith approach. Okay, that's all from my end. We can move to the questions.
I think we have few questions in the Q&A.
So the first question is why fact tables will be created after the dimension tables? I thought fact tables primary key will be added as a foreign key in the dimension tables. So it's actually another way around in our case. So we have the lookups, the keys from lookups gets added to the dimension tables, and dimension tables key. And we have not used the primary key and foreign key here. We have used the surrogate key because dimension in the dimension model, you'll have to move away from this primary key and the foreign key. We have used surrogate keys for that. Okay. There is one more question. What is the difference between landing, metadata, staging zone, and bronze layer? Okay. So there are in raw layer, right? So we are there are few data sets which are external to the organizations. So we are not that we are directly we cannot directly process these external data sets because we are not sure about the quality of the data which we are getting from external world. So what we are doing is we are first dumping those data sets into landing area. We are doing some sort of checking on top of it, and on successful validation, we are copying that data from landing to actual data folder. And on the metadata, so we have a few tables or few files which are internal to the applications. We are ingesting data by calling REST APIs, right? And we have used data ingestion framework which is generalized. And for that data ingestion framework, we have kept a couple of files in the metadata folder. These files are mainly API endpoint details, and these API endpoint details are simply kept as a CSV file into metadata folders. So data ingestion framework can pull those CSV files and can start pulling the data from these REST API endpoints. Yeah. There is landing. I explained the metadata. Then there is staging zone. Okay. So while copying data from landing to directly data folder, and or there is again while copying data from your Delta tables to the Azure SQL, you'll need to stage that data somewhere in between. So it is data factory's way of doing it, copy. So we have used that staging zone for that purpose. Our Power BI reports rendered in React application, is there a Power BI report component that is available for React? Okay, so for that, right, I'm not dedicatedly worked on that part of it, but our team has a few Power BI workspaces created, and these individual reports are getting rendered as a React component on the application on the UI. Yeah. Hope this clarifies.
I think there's one more question. Okay. We've got the response. Thank you. Thank you, Rahul, for the wonderful session. Thank you, everyone, for joining in.
Thank you.
I'll be sharing the feedback link in the Zoom chat. Please do share your valuable feedback.
Recording is stopped, right?
Stopping Aditi. Just a second. I'll just put the link.